it's right. Oh,
I got right number but wrong point.
Maybe it's my mistake. I don't know.
Huh?
Which question?
Oh, yeah.
Yeah, that's right. Because two hands.
Yeah, I got it.
But it's still tricky.
There it was.
Yeah.
Centimeter.
Yeah.
Centimeter square, cent square.
Yeah.
So, when I change this calculator to Casio,
Yeah.
can I use the 10?
10?
Yeah.
For what?
For the G.
No.
Because of my calculator is too.
You need to buy a new calculator.
No excuse.
Exactly. Exactly. Alright, let's continue. So, next lesson here. Conservation of energy. Easy. Yeah.
You say it.
Yeah, it's true. Okay, if you can write this down first.
Okay.
Mm-hmm.
Cancer. Okay, you will explain. Okay.
Yes, I will explain, don't worry. Well, maybe somebody knows this word, conservation. No?
I even
Maybe you say no.
Might be okay.
I even
Maybe
say
Gav knows.
I know it's conversation.
You know, conversation is
That's
different, yeah.
conservation.
I know communication.
Yeah, that's also different. Okay, let's continue then. So, what is energy? Oh, what's wrong somewhere? Come on. Yeah.
Power.
Yeah, so what is energy? So, if something has energy, what do we mean? Or if something is energy, what do we mean? So the definition is quite simple actually. In physics, something has energy or is energy if it can do work. So, I have energy because I can do work. That's what makes me have energy. That is the definition in physics of energy. It's being able to do work. If you can't do any work, then you have no energy. You'll need this definition for the exam. So, it's in physics something has or is energy if it has the ability to do work. What's confusing you?
No.
No? Okay.
Oh, I never done this.
On this?
So that means I have to move with so I have the energy.
Mm-hmm.
If I don't move, I don't have.
No, you still have the energy because you could move it. You have the ability. It's inside you. You know what I mean?
Yeah, I know.
Yeah? Continue? So, you also measure energy in joules. No work means no energy. No energy means no work. Simple, okay? Usually though, the work done is less than or equal to the energy available to do the work.
Yeah.
So you were saying if you move something, you have energy. If you don't move it, you still have the energy. You just, like on your phone, like the battery, as you do work, your energy goes down. Yeah? So, the work you did must be less than or equal to the energy you had. You understand? You can't do more work than energy you have.
So we
Okay.
will learn effective.
Yeah, efficiency. Very good, Ben, very good. Normally for physics, we just simply say, if I have 1 megajoule of energy, I can do up to 1 megajoule of work. But often, all the energy is used. So, usually for most questions, the work equals the energy. You know, something uses all its energy to do some work. So sometimes I might say work, but maybe I mean energy, or sometimes we say energy, but really we mean work, because often they are equal in the question. Yeah? Okay, so you have this definition, and you understand this?
Yeah.
Okay, good. Right, so there are actually many types of energy. That is, there are many things that can do work. So we're going to have a look at all of them. Well, not all of them, but a few of them. So, first type of energy, and you'll need to write these names down. The first one is electrical energy.
What?
So,
Electrical.
ELE.
this here, electrical energy, this can do work,
Yeah.
because I could plug something in here and it could, you know, make a machine move. You could do something.
How to spell it?
There it is, electrical energy.
Okay.
Yeah? This is an important type of energy. Oh. Very important. Yes? Okay, continue. Right. The next one is magnetic energy. Because the magnet could move something. Like a person could push it. The magnet could move it. So this is magnetic energy. Are you writing these down somewhere?
So the name is important.
Yeah. Of course the name is
For
important.
you.
Especially for you.
Okay.
Did you get the last one?
Electric and.
Write it down, come on. Electrical energy.
Yeah, I know the word. I know.
Did
the
you
word.
write it down?
Sorry.
Thank you.
No problem.
Okay. Next one after magnetic. Delicious type of energy. Chemical energy. This is the energy, for example, in food. Ah, Ben, do you mind getting that? Thank you.
Chemical.
This energy tastes good.
Maybe not.
We're doing energies, types of energies. Yeah, so we haven't gone to that one yet.
This chemical.
This is chemical. Yeah. Next one. So, this one is energy you get from the sun.
Solar.
Like solar energy. Yeah, so we call this radiant energy.
Radiant. What is radiant?
Solar.
Solar. Okay.
But it's not only solar. It can be like X-ray
Okay.
and all this stuff.
Alpha. Theta.
Yes, all this type of stuff. All this type of stuff. Yeah. Okay, continue. Are you writing these? Good, okay. What's wrong?
I forgot the Chinese word. How to write down?
For what?
Radiant energy.
Ah, just stick to English. Just stick to English. Why do you need to write the Chinese down? Go! Why do you need the Chinese?
I can't remember radiant.
Ah, no, you need to try to remember.
Just have me to remember.
Okay. You could draw a picture.
No, how?
What do you mean, how? It's so easy, look.
It's just. Okay.
Right? Continue it.
Okay.
So the next type of energy, see, I told you this lesson is easy. Next type of energy is nuclear energy.
Nuclear.
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 Nuclear is chemistry.
Yes, correct. Yeah.
But it's same word?
No, it's
No,
not
same
same
word.
Okay.
Well, it's the same root. Not the same word, but the same origin. Do you know what I mean?
Nuclear.
Like the same family.
Nuclear.
Yes.
Yeah.
Nuclear.
Nuclear.
The tree sounds. Yeah.
Who?
What? No, Chinese. What are you saying?
Boom.
What? It's oh. Summer, it's okay if she forgets it in Chinese because she needs to remember it in English. Yeah.
After English is proving I forgot a lot of
Yeah,
Chinese.
that's a good thing.
It's
All
not
right.
a good thing. It's not a good thing.
Continuing. So after nuclear energy, we have ionization energy. Now wait. Did you do this in chemistry?
Yes.
Ionization.
Yeah.
So you know that when an electron is trapped, you need some energy to free it.
Yeah.
Yeah. So like there's a
Too close.
energy involved with being in an orbit around a nucleus. So this type of energy is called ionization energy. Okay.
But we will talk about this
Next semester.
next.
Next semester, yeah. You got that?
Yeah.
Yeah? Okay.
So we have exam after we holiday back to holiday.
Maybe. I have to talk to
After or
Connell.
before?
I don't know.
Okay.
Which would you prefer?
Neither of them.
Yeah.
If you had to pick one, which would you pick?
I don't know.
I believe
Exam before or after the holiday?
Cause I don't think I have enough time to review them if I don't have holiday. But if we have exam after the holiday, I couldn't spend my holiday well. You know.
yeah.
You have to
Just-
think about this.
That's
Neither
true.
of them.
So we will have exam.
Before better
Midterm.
after
Midterm.
Midterm
midterm.
Midterm. Middle semester.
Middle
Why?
exam
Why?
Yeah. Why? Because we want to know how you're doing.
because we have a holiday.
Yes, that too. All right, next type of energy. Elastic energy.
Did you play this?
No, I didn't. I'm good.
You're good.
Elastic energy. The energy inside elastic materials. Okay. The next one now is gravitational energy. Because think about it.
Big
This
G.
this sun could pull things into it. So it's doing work. So it has energy. It's gravitational energy.
We will learn this.
Oh, of course.
Yeah. But I don't like this.
I know, it's very interesting.
No interest.
It's very interesting. Yeah? Yeah?
Yeah.
Continue? Okay. So the next one, heat energy.
Heat.
Mechanical energy. See, so many types of energy. I will fine you if you speak Chinese. Maybe €5 each time?
Oh,
Maybe.
€5.
Maybe.
I will become poor.
Yeah.
Poor.
Yeah. Right, you got that one? Mechanical energy. Now, the next one is wave energy.
Wait.
€5 and
No, no,
€5.
no,
No.
I say nothing. Just something.
This is actually an important form of energy because it's energy that is not being used. We get most of our energy from fossil fuels.
Is in terms of movement.
No, that's tidal energy. This wave energy is
Wind.
wind and storm.
But what's the difference from the electrical energy? Because the wave energy can make the electric.
It can. Yeah.
What's the difference?
There is no difference. You can change it.
Yeah.
So the wave energy can become electrical energy. Yeah. In Ireland, we use a lot of fossil fuels. Do you know fossil fuels? Coal, gas, oil.
Yeah.
Yeah. We don't use this energy, which we should, because we have a lot of this energy in the west. Yeah, west of Ireland has lots of this energy. In fact, of all the countries in the world, Ireland is number 3 for this energy. It has the 3rd most wave energy.
Which is the first?
I don't know actually, I need to look them up. I think you need to think of countries that have a very rough coastline, very stormy weather on the coast. But we don't use this energy.
Russia.
We use this.
Russia.
We use this to
Canada.
stop.
I don't think they would have as much
Canada?
of this energy.
What of Russia?
Again, I don't think so. I think you need to be looking places like maybe in South America where they get very bad weather.
Yeah.
I think this is where. Yeah. Continue.
Okay.
Yeah. The next one is kinetic energy. This is the energy something has because it's moving.
What is the meaning of
What's the meaning of what?
the
Kinetic
kinetic
means movement.
movement?
Yeah.
But I,
Move energy.
Yeah, so let me explain. Suppose, think about this. Suppose you have a box and you want to move this box, let's say 1 meter. Then you have to do work. And you can do work by pushing it. Or you can do the same work equals if something is moving here very fast and it comes along and hits it, this will move. So this has done the same work as this man. And the reason it could do this work is because it was moving fast. So by moving fast, you could do work because you could crash into something and apply a force. So it has just moving has work, has energy. Yeah? Do you get the idea? You
No.
sure? No. What's confusing you?
I say nothing.
Okay, right.
Okay.
Potential energy.
this and loss is
Together, yeah. This has energy because of where it is. Because it's up here, it could do work. If you push this a little bit, it will fall and break this rock. Yeah, maybe. So it's like you apply a force. It has the same effect. So this has energy simply because of where it is. That's potential energy. Yeah? Okay, continue? Right. Now, finally, conservation of energy. Okay, I'll say this. This is the most important rule in physics. This is most important. And the reason it's the most important is because it's always true. There are no exceptions. So the conservation of energy, what is it? So important? Let's have a look. It says energy can be neither created nor destroyed. So this means you cannot make energy or destroy energy. You can't make it or lose it. All you can do, the only thing you can do, is change it from one type into another type. So this electrical energy, I don't use it, I just change it. So I could change this electrical energy into light energy.
Okay, but what could you change wave energy to?
Which one?
Wave energy.
You could change it to electrical.
By turbines? Like
Yeah. I saw a YouTube last week about it. There's these little things that float on top of the water, and they bob up and down, and they run a cable to the coast, and it generates it this way. So you can do that.
What
What's your?
of potential energy? What could you change it to?
I've seen you could easily change potential energy into mechanical energy. So what I've seen before is like, you have like a weight, and the weight falls and it turns a
The
cog
way,
system.
Yes.
Yeah, and then you could change that mechanical energy into something else. Yeah.
Yeah.
You know this from? You know this? You've seen it?
And lastly, sorry,
Yeah.
the gravitational energy. What can you change it to?
The easiest one to change it into, let's see, what could easily change gravitation into?
And
Kinetic.
Okay,
Kinetic.
How, please?
Well, if you can imagine something that's in orbit around the Earth,
Yeah.
if you slightly knock it out of its orbit, it will fall to the Earth,
Yes.
and it will gain kinetic energy. That kinetic energy was originally gravitational. Do you understand how important this is? You can't make energy.
yeah,
You can't make it.
but we can lose.
No, you can't lose it.
Oh.
Exchange.
You can exchange it.
Change.
Right. So when I lift this up and I do work, where did I get the energy from? Where did that energy come from?
You said about
Your lunch.
Correct, my lunch. Correct. So I had chicken curry for lunch. So there was energy in the chicken curry. Where did the energy from the chicken curry come from?
chicken.
The chicken. Where did the energy from the chicken come from?
Chicken it was where
Her mom.
the energy
No.
come from.
Yeah.
Chicken it was where the energy come from.
Yeah, well, what does the chicken eat?
Grass.
Grass, okay?
Yeah.
So the grass had energy.
Yeah.
Where did that energy come from?
Solar.
Solar.
Yeah.
Where did that energy come from?
The solar energy.
What?
Where did the solar energy come from?
Radiant.
Yeah, but where did that come from?
Oh.
Do you see what I'm saying? So, you
It
can...
come from another energy, right? All the energies.
From the
Yeah.
green
And
from
Yeah?
the plants cell.
No, you've gone the wrong way. We're at the sun. Where did the sun get its energy from?
It's
From
chemical.
Brown.
No.
We couldn't get an answer. I know.
Nuclear.
is the heat
Yes.
energy.
Yes, the sun got its light energy, from nuclear energy. Nuclear energy. So my point is this. All the energy is just being changed. So for example, this light energy that's coming to your eyes, the radiant energy,
Yeah.
that was electrical energy.
What the chemical energy? Sorry.
Yeah.
Chemical energy. Where does it come from?
Well, if it's food, like if it's like potatoes or rice or something, that comes from the sun.
Okay.
This is radiant energy.
Yeah.
If it's animals, like chicken, they got that from eating plants,
Okay.
which got its energy from the sun. So basically all food gets its energy from the sun. It's just how many steps. So if you eat something like an apple, it comes from the tree, which comes from the sun. If you eat something like a chicken, then there's an extra step.
Yeah.
But it's the same idea. Interesting, no?
That's why watching the screen long
What?
time.
What?
Okay.
Okay. Did you write this down?
Yeah.
Yeah. I would like you to write above this the most important rule in physics. The reason it's the most important is because every rule in physics has an exception. Do you know what I mean by exception? There's, like, take Newton's formula, F equals ma.
Yeah.
That formula is not always right.
What?
sometimes it gives the wrong answer. If the acceleration is too big, then the formula doesn't work properly. You know, my point is every formula doesn't work perfectly, except
This one.
this one. This is the only thing in physics that always works ever. Okay? So really, my goodness, this is so important. There are no exceptions to this. No exceptions. Yes? Okay. Did you write that down? And did you write down it's very important?
Yeah, the most important rule in physics.
Yes, absolutely. Okay. Right. So, the only questions, and we can do them for a couple of minutes, no calculations, all English. Yeah, wonderful, huh?
What kind of energy comes out from the laptop?
Yeah, heat definitely.
Fans,
Yeah, heat, what else?
Electric.
sound,
No, coming out of the laptop. Coming out, not going in. Radiant energy,
Radiant.
heat energy,
Heat energy.
and I didn't say this one, but sound energy.
Wind.
Wind energy, yeah, because the fan, yeah, true. No, chemical energy is not coming out.
Just the inside of
It's on the inside, yeah.
is the word desirable or desirable?
Like something that you want. It's a good thing.
Okay.
Yeah.
It's too long, like
Ah,
really
it's not. Oh, come on.
long.